Before we look at the pigeonhole principle, I just wanted to find out if you had questions on your homework. So on your Wiley Plus account, you can go to assignments, and then every Sunday night you'll have to hand in homework. Hopefully, well, you should do it throughout the week, but if you haven't by Sunday night, then for sure Sunday night sign in. Did you get a chance to look at some of these? No. Okay. Yes.
When you mean hand in, you mean like
submit.
Okay.
Yeah. Yeah. So submit on Wiley Plus and on Canvas as well. So we'll look at Canvas also. So this Sunday, just in Wiley Plus, just chapter 1 is due, and then there's a couple things in Canvas we'll look at. Did anybody look at these questions and have questions? Which one?
Specifically chapter 1, like 1.1, like the square thing. Like there was 2 correct answers, and I know one of them was like none of them had a gold square in its center.
Oh yeah,
And then the other right one.
This one.
Yeah, the other right one was each was 1/3 the size of the whole square. Like when you split that up, it's like that doesn't look like 1/3.
Yeah, I see what you're saying. So for people who didn't get a chance to look at it yet, I'll read the whole thing, but I know what you mean. One day, Sierpinski began a creation with, as always, a perfect purple square. However, one square seemed too plain, so in the exact center, he added a gold square. He saw that the central square implicitly defined 8 purple squares. See, 1, 2, 3, 4, 5, 6, 7, 8. 8 purple squares surrounding it. As he pondered, he realized that those 8 purple squares were identical to the original large square except for 2 things. So we're comparing this square with one of these little squares, these little purple squares. So each was 1/3 of the whole square if you look with a ruler measurement. So if you took your ruler and measured this and then measured this, it would be 1/3 as wide. So that's what they're talking about when they say it's 1/3. And compare this to this, they don't have gold square in the center because we're comparing the big purple one to one of these little purple ones. Not 1/4, not a half. None of them had a gold square in the center. None of them had a silver square in the center. I don't think you have to check this one though.
No.
Let's just check and those 2, okay. So those are the 2, in case you're wondering. What other questions did you come across as you looked at chapter 1? Anybody? Sure.
And then like 1.4, like I couldn't figure out how to solve it without using algebra.
This
Because
one?
with algebra, it's like a fairly easy equation.
I agree. This is the one with the dog biscuits?
Yeah.
Yeah. So, so this one with the dog biscuits, mine has 56. Everybody's going to have a little different. So without using algebra, we're going to guess and check. So I'm just going to write it down. 56 biscuits on mine. 10 pets. Each pet's either a cat or a dog. Each dog is to get 6 biscuits. And each cat is to get 5 biscuits. So I'll show you how you do that with guess and check in a minute. And we're going to do it without algebra. And we're going to find out how many dogs there are. And again, yours will have different numbers, so you're going to have to do your own guess and check. Are there any other questions before I exit the Wiley screen? Then in Canvas, you'll also double check on Sunday nights to make sure you have everything in that you need. So for this Sunday night, there's that picture of dodgeball that we did in class on Wednesday. And then today you brought 1 million items, hopefully. We'll talk about that in a minute. So you would submit a photo of your items along with telling me what they are, because sometimes I don't know what you mean. Also, your name is supposed to appear in these photos, or a picture of yourself, or a picture of your placard. Okay. So let's look at this question from Wiley Plus. So one way to do it is to write out the 10 pets. And then do a little guess and check. So there's 5 cats. I mean, each cat gets 5 biscuits. So I knew at least some of the animals are dogs, because if I had 10 cats, that would only be 50 biscuits. So I'm just going to put 5 on a bunch of these. And then I'll put dogs' biscuits on a bunch. And then I'll see how much that adds up to. So this would be 30, and this would be 24. So that's only 54 biscuits. Okay, so my first guess was not right. I need more biscuits, so that means I need more dogs. In fact, I need 2 more biscuits, so I need 2 more dogs. Okay, so now I'm going to try again. If I have 2 more dogs, then these many are cats, and that's 20. 1, 2, 3, 4, 5, 6 would be dogs, and that's 36, 6 times 6. So that's how I'd figure out that I need, how many to be dogs? 1, 2, 3, 4, 5, 6. 6 dogs and 4 cats. So that's guessing and checking without using algebra. Did that answer your question? Yeah. Okay.
Just guess and check.
Yeah, guess and check. You need a few more biscuits, change some of your cats to dogs. Okay. Any other questions? Now, as you're in your classes this semester, some of you are attending college for the first time. You should write down what your teachers write down in class. Okay, so sometimes my students are a little bit lost, and when I look, they're not writing notes, and that explains sometimes why they're not in sync. So we're looking at section 2.1. We're going to look at a pigeonhole principle. But we're going to start with your million items. So for class today, I had asked you to bring a million items and a ruler. Who brought a million items, or what million items did you bring? Do you mind telling what you brought?
I brought a million grains of sand.
A million grains of sand. How much sand did you have to bring a million? Did you kind of measure it, or one bag, or?
I put it in this jar.
Okay, so it looks like a quart jar. 1 quart. Wonderful. I know from past classes that is more than a million. You can look on Google if you bring something and you're not sure it's a million, so you definitely have a million. So what you would do is you'd put your sand and your placard together, take a photo, and drop that in Canvas. Great.
I was going to try and weigh it, but I didn't have a scale, so I'm just going to pretend it looks perfect.
It is definitely a million at least. I can't remember how much it was, but I think it was around a cup was a million. Okay, who else brought a million? Yes.
I took like a picture of like this field of grass.
Grass?
That,
1 million blades. As long as you take the picture yourself of the grass, that's great. Please don't send me anything that was online, like $1 million picture online. I'm pretty sure you did not have that in your dorm room, okay? So your picture of 1 million grass, that's good. Yeah. 1 million blades of grass. So you should probably Google to see how much area you need, but I'll just assume you did that. Okay. What else would there be a million? Did anybody bring another million items? Yes.
1 million drops of water.
1 million drops of water. Then I brought a million as well. I'm pretty sure. Did you see how many drops there are in, it looks like you have 2 cups there, or 3. Did you happen to Google that?
No, I just took a picture of when it was raining.
Oh, you took a picture of raining. Okay. That sounds really good. I think I brought a million with, but I'd check on Google to verify that. Or if you said molecules, then for sure my cup of water would have 1 million molecules. Anybody else have 1 million of something? Well, these will give you some ideas then, okay, for your Dropbox, and you don't have to go with these ideas. You can think of your own million items. We're going to look at the pigeonhole principle today. Each class, your author starts the section with a question. Today's question in 2.1 is how many ping pong balls are needed to fill up the classroom? So we're starting to think quantitatively instead of qualitatively. What does quantitatively mean? Anybody know what quantitatively means? That you can measure it with numbers. Good description. So in our effort to move to quantitative, we're thinking about what might have a million items. And we're going to see how many ping pong balls are needed to fill up the classroom. So I'd like you to guess that. I'm not going to guess because I actually went through this with the last class and I have a pretty good guess. So I'm not going to write my guess down, but you go ahead and guess. And we're going to talk about moving away from answers like a whole lot or at least a million to a little more precision. So that's why I asked you to bring a ruler. So we're going to form groups. And then we're going to measure the classroom and measure ping pong balls and find out. We'll go ahead and find out how many ping pong balls to fill this classroom. So if you're at home watching this, then you go ahead and measure your classroom too, or your dorm or wherever you're at. We're going to work in class and do that. Okay. So let's see if I can get you into groups. Hopefully every group will have somebody with a ruler. So how about if you four make a group up, please? And then, so that leaves 16. You might be in the next group? Okay. Okay, so you be in that group, so there's 5, and then there's 5. And then you 4 can make a group, okay? And then, how about you 4? And then you can be a smaller group of 3. And then there's a group of 4. Okay. Do you guys have a group?
I got it. I think.
Yes, this will involve walking around and measuring. I will give you a hint. Look at the floor tiles.
Yeah, that's what I was thinking. I told you, bro.
Good. I will also bring you a ping pong ball.
Match them up to 4. Cool. And then, I need oh, perfect. Cool. 2 packets. Actually, 8. So, oh, shoot. I like talking about
Oh, it's supposed to break full gravity.
Oh.
Yeah. And then put it foot by foot.
Yeah, so it's just changing my calculations.
So we're a foot by foot.
Alright.
Let's just fill up to the bottom of the top, okay? So you can teach.
We got 1. About almost an inch. About 9. 9 here, 9 here, 9 times 9. Now, I need about. Okay, so 9 times 9 this
cut
is
out,
approximate for
just
it.
measure
That
it
one.
there and there and split the difference. Okay? 'Cause
And
it's
now,
not
can
cut
I
out
times
there,
it
cut
by
out there, it's
9
square.
more, if I want to go up 9?
This is
20,
21 right here.
and this is
So I'm gonna times it by 9
30
more.
long, and you use
Oh,
25, that'll be good.
786. Oh, 29. So that's basically my top block right here, alright? Now, we have that. We have this width of this whole thing. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20.
Yeah. I think I'm like halfway in between. Like,
34, okay. We got 34 tiles across, and then
So we're
1, 2, 3, 4, 5, 6, 7, 8, 9, 132.
one square.
32. Okay.
probably try to figure
Now how fat is this? 1, 2,
Yeah, I was saying, like, take this line.
Of course.
And then just
25, 26, 27. Okay, so
that's 20 to the wall, and this is 30 to the wall.
okay, so that's 27.
And that'll get the
So I got this.
I made those numbers up. I don't know what it actually is.
Oh, okay.
So someone still has to measure.
Oh. Oh, okay. So it actually has to do it.
It makes sense in
Yeah, we decided to get like
That'd be one.
because of that, I think we'll just use like little cubes, like pretend it fills up a cube. I know when you shake them together, they're kind of filling all this space.
I'm so smart. Watch me get the actual answer.
30.5. Can we like round, like, we got
we're
measure the tiles, right? And like 30.5 squares.
Oh, you're doing centimeters? It probably is, but everybody's in inches, so I'm gonna be doing inches, but like you're looking for how many
How are you doing about?
So,
20 what there? So like
30 centimeters per how wide
you don't
how
mind
is?
doing
Yeah.
I get that.
okay, so let's just say 30 centimeters. And then,
we could just measure the room.
I think I got it.
Do the.
3 centimeters.
So all you gotta do is figure out what was about that.
So then you would say like,
Well, that's what she said.
It doesn't look, did anyone measure the wall?
it's way more moist than pen.
Okay, and then you cut it.
Oh, wait, we don't know the area. Okay.
Okay, about 10. About 10.
I just added up.
I'm sorry, I'm doing work.
Okay, so this is in the middle and then, okay, so this is 21.
Bam! That's how many you get.
The area, but.
So that should
I doubt it though.
hopefully.
Wait, but.
So 300 divided by 3 is going to
We estimated
be what, 300? 900 divided by 3.
Yeah.
Well, how tall are you?
I'm I'm a 6.
Well, can we get the area of the circle?
Bro, I think
Across from here, so it's one that's red.
Oh, so we don't have to.
Oh, yeah, how far can you reach it, bro?
Almost exactly.
Now you're gonna have, I don't know how to do them all.
So we'll round that up to a 28, because there's probably a half over here that we didn't count.
So 28. So this is 28 and that's 21. So cut both of them in half and add them together. Supposedly. 28.
Well, it's 22.
21.
And that's 11.
Do we need to, Mrs. Edson, do we need to bend the volume?
The volume?
Yeah, on the sphere.
You can pretend the sphere is in a little cube box.
Okay.
Because I know if you shake them together, they get a little closer than little boxes. But this will be a good estimate.
So we have to convert 6.2 feet to.
But you can only fit what, 11?
Or we could do it for 27
Keep it on.
Is that right?
So whatever number you give,
I think so.
multiply by
32, and then it says with yeah. What was it? 32?
Then that's right.
yeah, 32
So do you-
times 25 times 8.
So that was the area?
The volume. Yeah, that's all. We're good now. Yeah.
Pause?
Yeah, I don't find it. Then we need to figure out how many times.
But then there's like, we have to do something with like the cubed square.
Well, let's work on this together. I see most of you have your measurements.
So you said that was
Let's work on this together.
so we have to figure out how many.
As long as we right to you guys, that should be it. That, this is the most important thing, 96. Yeah, one. That sounds right, like a box about this big, probably.
Okay, so who can tell me how wide this room is? From this way. How wide? 32 feet? Okay, great. How tall was it to the bottom of the clock? So we're just filling ping pong balls to the bottom of the clock in here. How tall is that? 94 inches. Okay. And how about length? Because we had these cutouts, I said to measure the long length and the short length and divide by 2. What did you get when you did that?
No, I don't think that was it.
Did anybody measure up to here?
It was.
Oh, all the way up to there?
Yeah.
Like in
That was
ruler?
like from here to there.
That one was like 21 or something.
21. And then how much was it up to here?
It was like 28.
28 and a half?
Why would we measure that?
So we want to know in the middle. We want, because the wall has this funky corner.
Oh, so.
Okay, well let's just, who's had this measurement? 28 and a half, did you say?
Yeah.
28 and a half? And then that one was 21?
21.
21 and a half? So we need 3 and a half plus 21. So we had 21 and a half and 28 and a half, and we're averaging those. To average numbers, you just add them up and divide by 2.
Wait, where did we get those?
So 21 and a half up to this short wall, and then 28 and a half up to this longer wall. At least that's what did somebody get different measurements? Okay. $25. So let's do everything in inches because our ping pong balls are little, and that'll be easier. If you did metric, that's good too. We should get the same number of ping pong balls, but most of the students were using the feet and inches, so I'll use those. So how do we change 32 feet to inches? multiply by 12. So there's 12 inches in a foot. Then how do we find the volume of the room? Who knows the volume of a rectangular solid?
Length times width times height.
Right.
So you said the length was 300 inches?
Yeah.
Can you scroll the paper?
Thank you. So 300 times 384 times 94. That's a lot of volume. $10,828,800. Notice those are cubic inches. You have inches times inches times inches. That's cubic inches. A cubic inches means a cube, 1 inch on each side. That's why it's named a cube, because of this third power right there. So 1 inch times 1 inch times 1 inch are cubic inches. Well, what about those ping pong balls?
1.5 inches.
1.5 in diameter? Now when you stack ping pong balls together, I know some would fill in here. We're going to ignore that and think of them as filling up a cube, 1.5 by 1.5 by 1.5. So if you guess a little more than what we get, it might be closer because we have this shuffled in. On the other hand, we have a cutout by the door as well. You see that corner is kind of truncated. So that space that we're going to not be counting might be taken up by the space that corner cutout takes. So we're getting an estimate that'll be pretty close, but not necessarily exact. So the cubic inches that a ping pong ball takes up would be 1.5 times 1.5 times 1.5, or 3.375 cubic inches. So how do I find out how many ping pong balls fit now that I've figured that out? Yes?
You divide by 3.375.
Yeah, good. Divide the volume of the room by the 3.375. That's a lot of ping pong balls. So we have more than 3 million ping pong balls, but less than 4 million. So if you were in that ballpark, you're doing pretty good. If you guess like 10 million, you're pretty far off, but it's understandable. And that's why we would want to take some measurements and get a closer estimate, so we can be more, closer to what our answer is. Well, we are looking at large collections. We're looking at what could you have that's 1 million items? How many ping pong balls fill the room? Another question along those lines are there two non-bald people are there two non-bald people in the world? And you can say yes, but I'm going to keep going. Okay. Who have exactly the same number of hairs on their bodies?
Is it still the pigeon principle?
Yes, this is still the pigeonhole principles. In fact, this is going to help us understand the pigeonhole principles. I think I used the wrong there. Are there two non-bald people in the world who have exactly the same number of hairs on their bodies? Okay, so there's several questions that this raises. One, how does the author's mind think that he would suggest such a premise? Okay, no, I'm just kidding. Let's see. Can we answer this? Is one question. And the second question is, if you can answer this, is the answer yes or no? So I'd like you to decide whether you can answer this question or not. And if you think you can answer it, would you answer it yes or no? So pick one of those, and I'm going to ask you to vote in a minute. So, dun, 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 dun. Who can do the Jeopardy song? Nope, you don't work in groups. Circle one of those, or write that you can't answer it.
Oh, I got it.
Okay, so who does not think that you can answer this? If you don't think that you can answer this, then raise your hand. So we've got quite a bit here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 people say you can't answer. Okay. For those of you who think you can answer it, would you answer yes? There are two non-bald people with exactly the same number of hairs. How many say yes?
Oh, yes.
You got one yes? Okay. One yes. How many say no, there are not exactly? 2, 3 no's. 4 no's. Okay. Does anyone remember what I said for this? 17. Thank you. Well, we are going to investigate by being more specific, just like with the ping pong balls. We want to get a little more specific. So what we're going to do is we're going to take a 1/4 inch area on your scalp. Okay, so if you pull your hair back like this, right here, and somebody in your group will take a ruler and measure out a 1/4 inch by a 1/4 inch. And then somebody will take and count those hairs out. And we're going to see how many hairs are in 1/4 inch by 1/4 inch section along your hairline there. So, who has your rulers? Take that out. If you're working at home, you'll have to use a mirror. And this will take a few minutes. So we'll put up the working sign. Working. So you need someone in your group who's willing to have their hair counted. And you need someone in your group who's willing to be counting that.
try to find an
I can have
I had some.
How about in this room? There's one of my editor accountant.
Waiting
So you found someone who's gonna do this? Okay. You gotta measure carefully so you don't have too many, because that's a bigger job than you need.
Yeah. Or you want to count a section? So the average that is like under $50,000.
Can I get your big profile? I think I'll do it. Did you call her?
I gotta take a video. There we go.
Don't count your percentage, they drop so many. And then the percentage of the rest is the percentage of your. So the total average.
So they're gonna look at all how many we got right now.
Not, each assignment is the same. So it does, so it averages your percentage. They do it all the time. And I don't know, I really can't do this. Like at 3, I would make sure you get answers. So you put 100, usually it's 40, so you jump 60. Oh, that's what happens. 140 minus 60 is 80. You had a ping pong ball? Did you have a ping pong ball?
Oh,
I gave it to
there.
you.
I was like trying, but it was so hard to find.
It's really hard. I've had everything from like 12 to okay. So I think it just really depends. I don't think they're closed evenly either. I think you are on some sides if you can.
Yeah.
Wait, so what happened?
So most times so far was 120, but
Think about it.
120 for this room.
So 5 million hair follicles is the average for the adult body. Yeah, so that's a lot of calories.
Yeah. Oh, did you go?
Yeah. One out of the, one and then, yeah, 5 million.
How do you even, so confusing. I need to get. Well, I don't know. Of course it. What was it? 16. How much here? Oh, so that would be this There we go. I have no.
It's kind of hard, but it is. Okay, that's fine. Yeah.
I'm over, I'm at 110.
So quarters by quarters, but yours went taller.
I worked 10 to 6:30.
So that would be right. So how many times how many?
Yeah.
And how many do you have? I think you guys did real good though, because I think this is a quarter and this is a permanent. So
I don't know the part on the weekend.
Yeah, so I don't know, a little bit more.
I think it's more than that. So you have a quarter and five.
Yeah.
That's not.
Alright. So what did you get?
Well, I think yours was what, I think you each had a quarter inch.
Oh, you want to
Yeah, yeah.
Okay, so.
So I have the most I found in the classroom for counters, which by the way, thank you for letting your hair be counted and for doing the counting. The most I had was 120. So we're going to see then the most that you would have in a whole inch. So if you have 120 hairs in a quarter inch by quarter inch, what do I multiply by to find out how many you have in 1 inch?
4.
That was a trick. It's not 4. What do I multiply by?
16.
Yeah, 16. So when you take a 1 inch square and you divide it up into 1/4 inch by 1/4 inch, then you have 4 one way and 4 the other, so 16. So in 1 square inch, 1,920 hairs. Now that's a lot of hairs in a square inch, almost 2,000. But some people will have more hair than actually are in the classroom. Can we agree that nobody would have more than 10 times as much hair on their head? So people outside of the classroom might have more hair than we actually counted, or even someone who didn't get counted here. But I don't think I think we can be sure that nobody would have more than 10 times as much hairs.
At most, maybe twice as much.
Yeah, you could even make it twice as much, but we're going to say we're going to be on the biggest possible hair. So what we're going to do is we're going to find the most possible number of hairs a human being could have. And so since we're going to find the most possible number of hairs a person could possibly have, we'll multiply our count times 10 and say nobody's going to have more than 10 times as many hairs per square inch on their body than that. Whoops, I forgot the word finding. We're finding the most. We're finding the most possible hairs possible. Finding the most possible number of hairs possible. Okay. Well, now we need square inches on our person. Get out your rulers. No, I'm just kidding. We're not going to measure skin. Okay. Instead, we're going to make Bob. Now, Bob happens to be shaped like a cylinder, but don't judge him, okay? We're going to measure the square inches on Bob of skin. So Bob is 32 inches around, And he's 72 inches tall, which is 6 feet. So the skin on Bob, you'd have, since he's a cylinder, you could actually unfold him like when you pull the label off a soup can, right? And you could pull the skin off. That sounds awful. Okay, so you get a rectangle when you do that, 32 inches by 72 inches. There's also the top of Bob's head and the bottom of the feet. We're going to find out the most number of inches a person would have. So we'll take the unwrapping the cylinder, so that'd be 32 times 72. And we'll add to that the circle on top of the head there, okay, and the circle on the bottom of the foot. Now I'm looking for the most skin that someone could have, so I'm going to use a little bigger number there. I'm not going to take time to find the radius. I'm just going to say 16, because 16 will be a little bit bigger actually than the radius is. Who knows the area of a circle?
Pi r squared.
Good, pi r squared. So 16 squared times pi for each circle. So I'll put that in the calculator and see what we get. So 3912.5. So I'll round that to 13. Okay, 3913. Square inches. Yes.
Where'd you get the 16 from?
So 16 is actually bigger than the radius is. But I didn't want to take time to do the algebra to show exactly what the radius is, because we are estimating and we're trying to find the most skin a person could have. So I picked a number that's a little bigger.
Okay, and then why did we multiply 72?
So 32 by 72 is the measure of the rectangle we get if we cut along the side of a cylinder and unfold it.
Oh.
Now, but most people aren't 32 inches around. Mostly, like, they have a neck, for example. So this isn't as much skin as the biggest person could have. But nobody's going to have more than 10 times this amount of skin. So no one has more than. We just put a 0 on the end and that multiplies by 10. No one has more than 39,130 square inches of skin. So we can find the most possible, we can find a number that's bigger than any possible number of hairs a person could have by taking this skin, these square inches of skin, and timesing by the hair, the most possible numbers of hair that we had. That was actually more hair than anybody could have. Let's multiply that out. So we have a lot here. 751,296,000 hairs. No one could have more than that. No one could have more hairs than that, because we took 10 times the most hairs per square inch, and then we took 10 times the most skin on an average person. There are 7.6 billion people in the world. So going back to our original question, now that we know the most number of hairs a person could have is less than 751 million, and that they couldn't have more than, that there's 7.6 billion people. Let's see if your answers change at all. Okay, so who still wonders if we can answer if there are two non-bald people in the world who have exactly the same number of hairs on their body? Who thinks we cannot answer this yet? Who says that we still can't answer this? Okay, so 1, 2, 3, 4, 5 people. Okay, so 5 people say no, so that went down a bit, so maybe these went up. Who say yes, we can know that there are exactly two non-bald people? 1, 2, 3, 4. 4 say yes. How many say no, there are not exactly two people with the same number of hairs? 1. Okay. So we're answering, are there two non-bald people in the world who have exactly the same number of hairs on their body? Here's what we're going to do. We're going to make rooms. Everybody with 1 hair goes in room number 1. Everyone with 2 hairs go in room number 2. Everyone with 3 hairs. Everyone with 3 hairs goes in room number 3. So we're making a room for everybody. Everybody will get to be put in one of these rooms if they have hair on their head, right? In fact, we'll put a room here that is empty because we already found out no one has 751,296,000 hairs. So this room is actually empty on the end. But we have every number in between. So if you have 5 million hairs, you're right around here. If you have 700 million hairs, you're right around here. We have every single room. Who all, is anybody left out of these rooms then? Everybody, well, bald people. Everybody but bald people should be put in one of these rooms, right? Okay. Does anybody want to change their answer then to this? Because we have 7.6 billion people and we're shoving them in to 751 million rooms about. Does one room have to have at least 2 people in it? Yeah, one room has to have at least 2 people in it because there's way more people than we have rooms. Yes?
But the 7.6 billion people is still people that are bald. So
That's true, but there's not, do you think there's more than 6 billion bald people?
But you still have to take that into consideration.
Sure, you're right. So you're right. But we'd have to have 6 billion bald people. And I'm pretty sure there's not 6 billion bald people. So I think we're still going to have to put 2 people in one room. So the answer to this is yes, we do have, on this planet there are 2 people that have exactly the same number of hairs. What we are working with is called the pigeonhole principle. And it says, if we have more objects, than we have boxes, if we have more objects than we have boxes, at least one box must contain at least 2 objects. At least one box must contain at least 2 objects. So that's what we had. We had boxes for people based on how many hairs they had, and there were not enough boxes to get to 7.6 billion. So at least one box has 2 people in it.
So that's the pigeonhole principle?
Yes, this is the pigeonhole principle that you will be quizzed on, and we'll look at some more examples of that in class on Monday, because we just looked at one example, so with the hairy body question. So we'll look at that more on Monday. Have a good weekend.
So what's the
The homework you can always find by looking on Wiley Plus and on Canvas and checking the due dates there. I think there's just one assignment on each.
I'm actually having problems getting on.
Do you want to talk about it outside of the classroom or email me? Okay. I'll just clean up here first.